Okay, retro friends, welcome back. This is another Pixitron demonstration. Today I am working actually on Pixie, and this is the follow-up to the introduction. So this is Pixitron, episode 2 of the Retro Lab Code series of Retro Friends. We're looking at some modifications I'm making here to the Pixitron engine. So here on the left, we're in drawing.js, and I've modified that file to resemble the round box constructor. This is a simpler form of creating a round box, and basically this has all the information you need to create a round box in a simple constructor round box, which creates and installs that to the stage. In Pixie, there is the concept of a stage, and on the stage you place your graphics. This is similar to Flash and Macromedia Director, which is a very old application. But basically, in a nutshell, a round box allows us to place a round box. This is just a test for me, sort of get things going. I realized last time I sort of quickly went through everything that's in this engine, but I didn't really talk about the specifics. So let's take a look at engine and how it works. So there's a couple of different ways that you can stylistically make classes in JavaScript, and the class symbol or keyword is one way to handle it. Now, I want to also kind of clear up maybe some question marks you have about what the whole Pixie PHP thing is. I've been thinking about it a little bit more, and I think that what we're going to do is a backend. I sort of forgot to include the page framework in our last intro video, so I want to talk a little bit about the backend. So I happen to have a demo of the backend, and I'm going to show it off right here. So we've got a JSON response here, and the message is no API keys found, and it's at a test site that I have for the Poppy framework. So a few years ago, not that many, maybe 10, I was a web designer full-time doing web development, and I've pretty much used PHP and PHP frameworks since the 90s. And for me, I don't really care that much about whoa, what's this? Yeah, wow, that's great. So anyway, I wrote this framework called Page, and apparently I haven't been to this site in a while, but this is github.com/h3rb/page. And what Page does is it's sort of like my version of an MVC framework. And an MVC framework is, a way to, in PHP, define a model, a view, and a controller. And this is a way to deal with a database and different views. And a lot of websites, including GitHub, sort of follow that method of MVC, model view controller. And there's other variations on this. There's MMVC, there's MVVC, there's MC, there's MCV, there's lots of that. So the first one I learned was actually no framework, and then I was sort of forced by the industry to learn frameworks. And eventually I got to a point where I sort of got sick of working on frameworks. Now, I've never seen this notice before on Page, but it says that there could be a security vulnerability in one of the dependencies. But when I click see security alert, I get a 500, and that's bizarre. Not sure what that's all about. Regardless, this is similar to, in modern terms, maybe Laravel or CodeIgniter. These were big frameworks back in like 07. CodeIgniter was still pretty big. There's also the Zend framework made by the people who made PHP. This is actually a little bit too much for what we're trying to do. So I've sort of moved away from having these all-encompassing frameworks. And while Page was a very minimal framework, it was simple. All you had to do was add a file to a directory, and the model would be added. Controllers and views, in my opinion, are really kind of the same in the web because you have to use the controller and the view at the same time, and really a view is compiled with many modules, and controllers are supposed to handle the logic and the security access, if you will, and all of that is sort of important. But the thing with these metaphors is that they don't always work out, and they break down. And MVC is from the 70s. It's something that covers old style VAX VMS systems and just older database systems in the 80s, which were all text-based terminal sort of views. Sure, it's similar. A web program is not that different than a email program from the 80s as far as the buttons that you might press and the functions that are going on inside of it. Certainly there's more sophistication in the web, but maybe not. Some of those older systems actually had more going on in them. But the whole point of Page was to make it really, really easy to add pages. In this case, we're adding a page that's not protected. If someone's logged in, it will, say a different message, but it doesn't bounce them anywhere. That's just an example. And you're welcome to take a look at Page if you're interested in that sort of thing. And maybe eventually I'll give some demos of Page. But I'm going to avoid Page because while a lot of the concepts in Page are being used in Poppy, it itself has some stuff that's built in that just may not be appropriate or necessary for what we're trying to do in a client-based online game. So our plan, Bill and I have a plan to develop a turn-based strategy game that's done online. And one of the things we want to do is have that account system where you have tracking of high scores and things like that. So in addition to Page, I actually made two modifications. One is PageMin or Pagemin, and sort of a joke on Pokemon Pagemin. And Pagemin is the minimal core of the Page framework, so it actually doesn't have anything other than the very bare minimum that you would need. And this is a good place to start. Some of these have little tricks that you have to know to get them going, but once you get past those tricks, you can, easily create things. If you look briefly at Pagemin, you've got these different folders. Some of the more important ones to the data model is model. Inside of model, you place files and it loads them into. It expects those model files to be named after the tables that are in your database, and by doing that, it can automatically make some assumptions about where the data is in the database. And if you look in core, there's some setup files in here. One is path, and really once you set this, the demo site should work. So wherever you've placed it on your web server, if you change path, you should be able to see exactly where those, see exactly the demo. It should work fine. There's some other stuff in here that you can set, like for instance, there's root, or not root. There's some utilities. I mean, just looking through these, if you've ever worked with PHP before, you're going to see some familiar faces in here. But I've launched several commercial products using Page and PageMin, and I actually did develop one non-launched product using Poppy. And what Poppy is it's a PHP API that handles just everything is done through a web backend, and the backend is completely JSON driven. So you don't go to a website and see a page and have to deal with the CSS and the JS. Although those folders are in here, they're built from Page. So yeah, those folders are in there and you could do stuff with them. But essentially, it does have that same model folder. If we look into model, you'll see that there actually are some models in Poppy. And, you know, I was just showing you a second ago, like this is a response from Poppy where we have, you know, a response code and a message. And this can look like other things as well. So I just happen to know that on this test page, I have a backend. And this is what the backend looks like. And you can see here that, you know, it's returned null, and it has a value of true. You can send these requests, and this is where you send that JSON data. And basically, the entire framework is based on the fact that you can send JSON through a special set of URL variables or, you know, other variable types. So let's just log in as guest real quick. So I sent a request. The response was this string, and this string came back with a server code of 200, meaning everything's okay. It validates the JSON, so if you get past those two steps, then the client knows that the response was probably valid in some way from the backend. So in this case, I sent the action login, which was recognized by the backend, and I sent the data username and the password of guest. So this data was sent preferably over an HTTPS connection, so you have SSL transfer. But in this case, I'm using a non-secure backend. That's just a test case. But you would change 1 or 2 lines of code, and you'd be able to enable SSL once you had a cert that was active and current. So down here, you can see that there's a raw response, and it's given us a session code. So it also has told us that you're not an administrator. So if the client were to have special features that only administrators could use, the client would know here that it shouldn't show those features because this user is not an administrator. So we're going to grab this session code and we're going to stick it right there. So we now have that token in there. And that token is stored in a database. So there's not really any cookies. You just need an active session code. And if your code is no longer valid, then the client, which is held on to presumably for the session, meaning the application's running session, it's held on to that password so it can relog in as long as it's open within the parameters that you decide as the developer how long you want that to be valid in the client. And the backend is going to, you know, maybe every 5 minutes destroy the session unless it's been updated. So every time I send the session token, it's going to refresh that session and it's going to keep that account logged in. And if it doesn't, then the client can respond, well, I want to log back in and here's my information. Give me a new session code. And so we're going to put that session token in there. Now, the only other action that works in this list, I mean, maybe this forgot works, but the only one that really works in this list right now is action me. And what me does is it says, I want this particular user's information. Give me my profile, a very common thing you see among websites. So action me with a session code will tell the backend, I'm logged in, here's my session, and I want to see what my profile looks like. So send me my data. Now, obviously, you could have actions in here that are different, but let me just do the request, and we'll talk about those possibilities. So I did another request, and I got a different string back. This time, I have a result of user, and in that, I have all of the data about this user. Now, of course, this is a backend that doesn't do anything, so it's no big deal that you can see my password and things like that. But normally this backend part of the website would be removed once you went to production. So only on dev would the backend folder exist, which has in it a file that allows you to put all this information in and do these test requests. So that being said, Poppy, the page API, is going to allow us to build multiple different types of clients if we want to, that all use a standardized back and forth JSON based communication setup using URL variables and session tokens. So if we look down here, you can see all the information is right there. It's up to the client and the server to follow the rules as far as what 0 means for email verified. But likewise, this could be the value false. It's all how you set up your database. However, in Poppy, generally, we have 0 meaning false and 1 meaning true. And then there's arbitrary integer values and float values or decimal values or doubles. And then we have strings. And we can also have JSON, which can be stored in a database, in a string or a blob. Those are MySQL or other types of SQL backends. Now, I'm not going to get into the abstract of whether or not MySQL or SQL itself or SQLite or whatever you want to use that is SQL based is not appropriate or appropriate. In this case, this is a very traditional system. We want accounts. We're not going to be using semantic matching. We're not going to be doing laissez-faire, sort of fuzzy logic or anything advanced. We're just going to be storing account information. We're going to be creating games. We're going to be asking for the state of games. And every now and then, the client or the server is going to perform an action. The server may shut down a game that's inactive. The client may ask the server to move a piece. And it's up to us to write the verification of that. So for instance, if I send a move to the server that's not valid, the server has to check to see if that move is valid. That's the most secure and cheatless way of writing this sort of thing. And, I've spent a lot of time discussing just the back end, but this is an important part of the development process for a multiplayer web game. It has nothing to do with Pixitron, but yet it does, because in Pixitron, we're going to be creating AJAX requests that follow these rules. Now, there's certain things you got to realize. You have to be able to turn off the dev tools, and you have to be able to hide these things from users, but you're not going to be able to hide things as well in a browser application as you are in a server-based application or in an Electron app, because you can hide the fact that an Electron app is a browser. And by doing that, you help, again, to protect against cheating. Now, it might be possible to modify the source code of an Electron app by hacking the executable. That's always true. But in gaming, cheating can be done in a variety of different ways, including in-memory modification. As long as the server is secure and it has a good picture of what's happening when you make certain moves in the game, it can protect against cheating, and cheating ruins the game for everyone. I mean, sure, it's fun as a single player to sometimes cheat to explore things about a game that you normally can't or find too difficult to achieve, but if you're playing competitively, which is the point of a multiplayer game, it's no fun if you've got a bot sitting on the other end doing all the moves. In a turn-based strategy game, depending on the settings that the players decide are appropriate, for instance, turn timers and things like that, those games can work out and be more fun and be more regulated. So that's why we're going for turn-based strategy. All right, so let's take a look here and see what we've got as far as data. We've got this, that's come back. It's been a little while. Let's do another request and see if it still works out with the same session code. Okay, so we were still logged in. It may be a 30-minute thing. It may not be. But I'm going to change the session code slightly and see if it still works. Session is expired or invalid. So if I didn't have that session token, which is really a temporary number, it's not going to last longer than 24 hours unless the user is constantly logged in. And if the user wants to, they can log out. So, let me I'm now not sure what the session code is, so let me hit the back button. Hit it one more time, make sure we have all the numbers in there. Okay, now I'm going to log out. So it had nothing to do with my IP, it had everything to do with this session token. I'm going to hit request again. I've now logged out. So that meant that because the code was 1 and because logged out happened, the server said, this is a valid session, you want to log out, I'm going to kill that session. So if I do the request again, it should say, and indeed it does, that the session is expired or invalid. So it was logged out, and that session no longer exists. And at that point, it's actually deleted it from the database. So let's try an administrative action. Didn't work. So let's log in. And let's just see what happens if we check as administrator. Let me give it a refresh just in case something's up. Okay. Well, that didn't work. So let's get rid of this session token. Okay. So again, it's validation of the incoming stream. If the information is incorrect, the server has to be properly written so that it will not send back or accidentally or falsely approve any transaction that's occurring. When I make a request and it makes a response, that's considered a transaction, and both sides have to be pretty carefully written so that they follow the rules that are being set in place by the developer, who in this case is you and me. So that's the back end. You can imagine all sorts of actions that you could do, like start game, play turn of game. You can see here we have an action that was delete a user. Well, instead of delete, it could be select, and then it could be the type of game. And you can have lots of data in a whole tree of JSON. And the server can be programmed to respond to certain branches of that tree of information. So in this case, if we wanted to, this is like creating a new game. This is like seeing who's on a game or finding out information about that game. And that's where we're going to go next. But let's turn this off, flip back to the fun stuff, which is writing the game engine, and get you familiar with some of the concepts. So it's an engine, but we're calling it the engine because this is the lowest level. This is the loop. This is the event listeners. This is the updater. This is the thing that sets in motion the rest of the experience. So let's just go through this and we'll have an idea of how this is working. So the engine class, when it's created, calls init, which also sets the frame time, which is 30 frames or 30 milliseconds. Okay, so when I do this, I'm calculating the floating point value of 30 milliseconds because a millisecond is 1/1000th of a second, and there are 30 of them. And then there's this .time, which is saying that the current time in the game, which increases by frame time every loop, is 0. Which increases by frame time every loop is 0. Then we initialize the events. So that's called from within init, and init is actually calling a lot of other inits. So getting things set up, getting things in the right place, birthing the engine, creating the scenario. So we grab, useful variables from the world. In this case, our world is a window in a document. We grab the document's body. Um, we could set up a canvas, but that's taken care of for us by Pixie.js. This actually may have been from an earlier demo. You can also see here that we're creating an array of elements. Elements are not the same as the things that exist inside of a drawing stage, as we saw earlier at the beginning of this video, where we had the creation of a round box, and then we're adding that round box to the engine stage. The stage of the engine is everything that's active on the viewport, but elements may be much larger, many elements, perhaps hundreds of elements that aren't being viewed or aren't active on the stage at that exact moment. For example, the map, everything that's on the map, everything that's, on and off screen area. Elements is a pretty low level thing, so I'm guessing that it's not a map, but it is something where there's an array of elements, there may also be an array of maps that you can choose from. Other information may be stored on the engine. So the engine has a mode, which is, are you editing it or not? Are you in the editor mode or not? Have you selected any tiles? So some of this is coming in from a game that I made for Pixie that was made entirely in the web and didn't use Electron, and we had an editor there. That stuff's coming in from there, and probably some of that will be there. So when you make a game, you often have to either work with or make an editor, and it looks like at this point I was trying to include that, or at least give an inkling of it, so that if somebody went and got the Pixitron starting place, they could think, oh, there's going to be an editor. Anyway, we go through some arbitrary things that we have to do. First, we have to go and get the window size so that we can calculate the size of the canvas or resize the active viewing area. We have to init all the events. Events may be anything from close a window, requests, anything that's queued, anything that doesn't have to happen right at that moment, but we would want to happen. Anything that's delayed, anything that is repetitive, has to happen all the time, would be an event. When we go to init controls, here we're calling that information that we saw in the previous video about the interface class. So in the interface class, and it's really just the interface stuff. This interface stuff is creating, these are utility functions that make certain things easier. Update the mouse position, things that have to be called for touch displays. Figuring out the keyboard input. In our interface class, we have a keyboard that is conceptual, so that we only test the keyboard once per cycle. So we're saying every 30 milliseconds, give me the current state of the keyboard. I don't want to get it more than once per cycle. And I'll then ask this class in memory, where is the situation as far as, what is the situation of the enter key? What's going on with the up key? Did it recently get released? Has it been released for a while? How long has it been released? Has it been pressed? How long has it been pressed? Is this the first time I've noticed that it's been pressed? I like to think of the interface as a watcher, as a state machine. And so when we init the controls in the engine, we're setting up that state machine, that observer that's watching the human interface, which could be the game controller. It's bringing all that and unifying it in a single application layer so that we can look at the keyboard, the mouse, any controller inputs, any VR inputs if that was going on, anything like that. And we're going to have all of that, and we're going to look at that, and we're going to update it in a snapshot exactly one time. So it's a photographer. It's taking a single picture per frame, just like we're showing a single picture per frame. It inits the renderer, setting up everything about the renderer, whatever the renderer would need. And then it has to set up the on resize, or I think in this case it's actually calling on resize, and it's saying, I've been resized, I'm at the beginning of my life cycle, but I've been resized from whatever the default values are, which in the case of JavaScript is undefined. Finally, it sets up anything arbitrary or important to the engine. And then we get into controls. So this engine class, so here we have literally what init controls is doing. It's creating that keyboard watcher. It's setting up a whole bunch of functions for on release. In this case, they're empty, but I could add something there. Like when you release numpad 2, it checks to see, or it calls some other function, or it creates some class. Trigger, it flips a switch, it does something. Same thing with these other keys, left bracket, right bracket. A lot of these keys are pretty arbitrary. They're just things that I pick. They don't do anything, but you could easily just add some sort of functionality to N0, which is numpad 0, and that's where you would put it. The left arrow keys as well. Do you want them to be mapped to the same thing as the numpad keys? Because numpad 4 is very much like the left arrow. So you could write a common function that's called in both of these places. Escape is going to close the window. Now, if you've run this application yourself, or if you saw the last video, you see that I hit escape to get out. And then I just tell the console, hey, if you're debugging this, let you know, keyboard is now initialized. It calls init renderer as well, and this is where we start to set up the Pixie application. We're going to set the background color for that application, and this is where Pixie starts to come into play. And Pixie has its own rules and needs. Everything above this was either Electron or JavaScript itself or gamepad.js, but at this point we're looking directly into Pixie, and we're creating a container, we're creating a display group, and in that display group we're creating a UI layer so that you can have an area of the screen that has buttons and windows and more webby type stuff. You're gonna need that, and you need it to be at a certain place in the z-index. So if you're familiar with z-index as a concept, z-index is how far forward or how far back. A greater value is closer to your face. A negative value is further away from your face. And so they stack like cards. And the first display group is the Z layer. And this is where you're going to put your tiles and your map. And you're probably going to change this number to a 10,000 or some high number so that you can place many objects that are Z ordered or not Z ordered within there. Now, as it turns out, Pixie display.js, which is an extension to this, which creates this display group class as a part of Pixie, has been included, and it allows you to do Z ordering. So you can say, I'm going to Z order by Y, and that's what this is doing. Every time you create a tile in this display group, it's going to be ordered by its position in a Y value. So very specific thing going on there, but that's what the Pixie display is. Let me see if I can find where that is online. Yeah, so here we have a GitHub for Pixie display. I'll include this in the links for this video. And basically it allows you to change the order of the Pixie containers without changing the scene graph. So your scene graph can be set up ordered by type or parent-child relationships, but your display order can be determined by your Z order, and this allows you to do isometric tiles and other types of effects. This is probably the simplest and most useful. There are more arbitrary types of ordering, which we can get into if that becomes appropriate. So you've got your UI layer on top of that, and then you can place things inside of that UI layer if you needed to, and dispose of them or hide them when they're not in use. Okay, now we're going to get the window size, which you saw from last time that there was actually an arbitrary scroll bar there. I'm going to have to work that out. I'm going to make it a little bit smaller so that when I run this application at the end here, we can see if those scroll bars still show up. We don't want those scroll bars to be there, but if they were there, maybe we could use that as a game element. There is a way around that. We'll have to look into that a little bit more. On resize, it's doing a couple of things. For one, it's getting the window size, which this is. And then in addition to that, and 30 is not a good number, by the way. It really should be set by a lookup to see how big the scroll bar is, etc., etc. But if we look at this, it's going to resize the renderer. So when we initialize the renderer, first we created a Pixie application, and then we grabbed the renderer out of the app and we placed it in the engines.renderer. So now this .renderer we can resize, and that's going to resize the canvas. It's going to modify the way that Pixie does clipping, depending on how you set up your renderer itself. It may change the size of something. All of that. It does tell the console, and if the renderer doesn't exist, it returns. Now, I'm not really sure why that's happening at this stage. It actually should happen a little bit earlier. That's an interesting one. A quandary. Perhaps a bit of code that needs to be removed. Not sure. Anyway, then it determines that if there is a renderer and it has an instance, and that instance is a WebGL renderer, then everything is good. Otherwise, we have a little bit of a problem. And that problem is that this is not going to work if you don't have OpenGL on your computer. This is a choice I've made. It's a little bit easier not to support software rendering, and most people have a GPU. They don't have to have the most amazing GPU, and as of 2020, any machine that's created, for instance, a laptop that has Intel integrated graphics, is going to support OpenGL up to 4.0. It may not have all of the amazing features that you would get on a full-fledged GTX GeForce card, but it is something that will be able to support OpenGL. So this shouldn't be an issue for most computers that were made, say, after 2013. I do feel like these two lines should go down here, so I am going to move those things. All right, now we're at the resize. That looks a little bit better. I'm actually going to commit this to the repo tonight, so these fixes will be in. And we've got an init. So during init, there's different types and different times that we want to init. And I created these two alternative inits. One is a deferred init. So this could be once the document's all set up and the engine's ready and the interface class is there, maybe then you want to make the menu. It takes a little bit longer, but at least you know that everything else has already been initialized. And delayed init allows you to delay that even further. So that's what those are about. Then there's engine setup. And in engine setup, we're looking at, what kind of an engine is Pixie? Well, it's a sprite-based engine. So almost everything in Pixie is going to be a sprite. So we want to be able to, I don't know, you can do whatever you want in here, which is why I say replace this with whatever. But in this one, we set a total number of sprites, and we generate a bunch of bunnies. You saw them in the earlier video, and you'll see them again in a moment. But yeah, those are sprites. They're randomly rotated in the beginning, and they all have the same update clause, which says rotate me by the amount that I'm rotating. Now, these are some pretty good values that you're going to want in here. You can do a lot with just these few values, and I happen to have a lot of AI code that's written around a lot of these values. So these are the most common things that a sprite needs. And if you look at GameMaker, and if you look at Unity, and if you look at other tools out there, you're going to start to see a pattern that these are the kinds of concepts that are attached to a sprite. The first one is tint. Okay, so if you remember the bunnies, and I guess I can run it again for you. Let me just bring it up real quick, and I'll remind you of what this looks like. So I'm going to run git bash here. All right, now it's a very tiny window, I know, but I'm just typing npm start. So if you look in here, you can see there are bunnies, and they are wobbling and turning, and they're all different colors. And if I scroll up and down, you can see that there's this little bit at the bottom here that is not being drawn on. So I'm still working on eliminating some of this, but it still has the scroll bar. So that stuff didn't seem to matter. I'm still working on it, but if you hit escape, you do get out of the program. Let me run it one more time, and by doing so, I will demonstrate the. Okay. So here is the devlog of all of the stuff that's happening, and you can see here at the very beginning, node is coming up, and I print out exactly what versions of everything are being used, and then I init the keyboard controls. I've initted Pixie. I show you what the engine looks like. You can start to dig into this engine. So you see that there's a renderer, and then that renderer this is a Pixie app. So the app is right there. You can open that up. There's a renderer. There's the screen information. You can see here that these values, you can even modify these values if you really want to sort of like experiment with it, but it's not that necessary. You can look at all of the information about the body of this document, the DOM, etc. We don't have any elements, but we do have entities, and those entities are these bunnies. If we look at this one, you can see here that we've got all this information about it, including a velocity that's a Cartesian. A Cartesian is a class that holds, your x, y, z, and an angle and some other information. And if you go down a little bit further, you've got your texture, and the texture is a bunny. If we continue to dig through this, we will eventually see that bunny, I believe, or at least get some information about it. But there's a way to sort of look through all of this information. So there are 100 entities because we chose arbitrarily to generate 100. If I change the value in the code to some number other than 100, we'll see something different. Then there's the frame time, which is 0.03, and we've got a height for our screen. Let me shut down this entities thing. All right, now we've got the UI layer, which is one display group, and it doesn't have any children. But in addition to that UI display group, we do have the ability to display things just in a div, for instance. And, it's been spitting out information, as it gets created, each of these entities showing. And here I'm showing how many entities exist. So I was just debugging the creation of these bunnies. And, deferred init was run, and then delayed init. So you could add things to those functions, like checking to see if you're logged in, throwing up a window, creating a new, playing a movie, whatever you want the beginning experience of this game to be, you could put that in those deferred or delayed init blocks. So that's basically what's going on with the engine.js. I'm going to switch back over to the code, and we'll take a look at what else is going on in that file, and then we'll move on for today. Okay, we're back. So we've created these 100 sprites here. There's the number on line 120 of engine.js. We've got total sprites 100. Then we're going through a for loop for those sprites. I mean, this is all arbitrary. We can delete this, and instead it would, whatever needs to happen next would happen right here. But maybe things in the background of a title sequence would be loaded. Maybe you would create entities that have some buttons so that a main menu could appear, because a lot of games start as a main menu. Could be a login sequence. Maybe you use JavaScript to create a modal, and even though maybe you do a star field in here, maybe you replace the bunny graphic with clouds, and then it's smoky in the background as you bring up your loading sequence. Maybe you're showing a movie on top of this, and you don't even see this stuff until you're ready to enter the game. So you have lots of different options here. It could be nothing, it could be something. You can always have the engine. As I get down to the bottom of the file, you'll see that I instantiate this engine. That's the thing about games, is that there's always this startup sequence, and then there's the actual game simulation, and then the game simulation is pretty much checking, hopefully only for when it's going to stop. But anyway, I'm getting ahead of myself. Let's move back to what's going on. So you saw these things in the devlog. It said, this is what's on the stage. These are the entities. These are the sprites. For every sprite, tell me about it. And then we added this ticker. So what's that about? Well, all games have a loop. And that loop is called many, many times a second. And if you remember in the beginning of this video, we discussed, or the beginning of this segment of the video, we discussed frame time. So what this ticker is a function that's being added to the ticker that's occurring every 30 milliseconds. And what's it doing? Well, it's whatever you want. In this case, it's causing the sprites, by going through the engine's entity list, to rotate by adding a arbitrary amount of speed to them. This is how you calculate, based on a direction and the scale and the speed, some arbitrary movement. So Brownian motion, or following another entity. Entities, the beauty of JavaScript is that you can just add pointers on, and when the pointer is disposed of, you can follow that thing until it's dead, or you can have that thing know about the thing that's following it, and onward and onward. So you have all these options here. So every 30 milliseconds, this thing is just going to go around and around, updating those sprites' positions. Super simple, not a lot of game going on, but it is a simple effect. So then there's the update. Update is going to be called by something else. It may not be happening as fast as the frame time, because you can only do so much in this ticker. You want this to be very optimal, but maybe every 30 seconds, 60 seconds, maybe every 1 second, you're calling this update. So it's all arbitrary. It's however you want to sculpt your engine and your game. And then you've got your renderer, and your renderer is going to render every time this is called. So you only want to call this during the main loop. So here's the main loop, as I mentioned earlier. And you're going to ask this over and over again to loop, loop, loop. Now, the update and the renderer are being called as fast as possible. This update, though, may be something like dispose of sprites that have been marked dead, or delete bullet holes from a wall slowly. You've seen that before in other games, and that's where that would happen. Or it could be check to see if the player's dead, check to see how long the player's dead, show an animation because the player is dead, that sort of thing. Game over. That's where that can occur. Maybe it clears out all the entities there. Maybe it calls a bunch of arbitrary functions that are part of a list of updates that have to occur. Whatever you'd like to place in there. It can be as elaborate as you'd like. So down here we add the event listener. We tell it to go once the application has loaded. And what go does is it says, let's create a new engine. And let's set up the request of animation frames for every 30 milliseconds. And let's call the delayed init after 1.5 seconds, which in our case is enough to load all of the graphics. But maybe in your engine, delayed init checks to see if a state has changed, and then once that state has changed, it stops calling itself or recreating this timeout. There's lots of different ways to handle these things. which is the beauty of JavaScript. So in addition to that, it looks like I arbitrarily created a new engine in the very beginning, and I'm not really sure why, but I know that when I do the go here, this may be, I'm not sure what we're doing here. So it looks like there's this event listener for once things are loaded, but then there's this arbitrary global call, and I'm guessing that that's because the engine has to exist slightly before it actually starts going. So this is the thing that is going to, oh yeah. So this inits the engine, and then this re-inits the engine as it sets up a loop. And that loop only occurs after the page is loaded, so after the document is ready. So a lot of this is thought through for you. It's available on GitHub. Please go pick it up. A resize event. I don't even know if I'm using this code, but it looks like there is a resize event here. I'm not sure when this gets instantiated, but obviously that function needed to be there. Let me just briefly look around and see if I can find out where that is called. So yeah. So this stuff here, this is the index.html file, and it includes Pixie and whatever. But when we required renderer, okay, if you go to the renderer file, it requires engine. So nothing's going on in the renderer. It just requires engine, and the engine sets up the renderer. So that's how all this stuff gets called. So it's in renderer that we set that up. Perhaps there is no resize event, because in my case, it's only as big as the screen. So it's generating a specific size depending on the full screen that's occurring. And that's all the stuff that's been set up based on the size of the browser window. So I'm going to have to look into that a little bit more. Initially, I had it running in a window, but this time I have it running full screen. And so I'm creating new utilities, ways to call things you're going to need, like a hit test or an orbit function where you can orbit around something, and it's expecting things to be in a certain format, coming in using the Cartesian class, which is a really great class for handling all sorts of things to do with rectangles, squares, and the like. And then I believe we're doing some box collision here. So just ways to determine if you've been hit by something works pretty good. Looks like we've put box 2D in here as well as chipmunks. So there's a couple of physics engines that I was playing around with before I released Pixitron. So Pixitron is coming with those things packaged. Thanks so much for listening, and I hope that you'll rejoin us when we're ready for the next Pixitron video. We're going to start creating a game from this starting place, and if you like Retrofriends, check out our other videos, other playlists on the channel. Thank you so much, and have a great time.